Okay, so I introduce the very first definition of the trigonometry. So in this class here, we learn three of them, three definitions. The third one is the most advanced one. So now I do only the first two definitions of the angle. We talk about the angle. Okay, so now definition one about the angle in the right triangle. That means this angle here have to be between 0 degree and 90 degree. We call it acute angle. So here the triangle here, so I put the angle theta here. Okay, so this one we talk about theta only. Okay, so now the line opposite here with that theta we call the line opposite of that theta, and the line here is the adjacent of this theta, and the line longest side in the right triangle we call it hypotenuse. Okay. Now this is all about study about the ratio between this line here. The ratio here, over here we name it sine. So we name, if I want to talk about the ratio between this line here over the hypotenuse, then the name should be sine of theta equal the line of the opposite side of angle theta. You see the line of opposite of angle theta divided by hypotenuse, the line of the hypotenuse. Okay, so we call it sine, just the name. Okay, so if I talk about the line here over that line here, we call it cosine. So sine here, sine, cosine. The shortcut is cosine of theta equal the line of the adjacent, and now I shortcut now to cannot write the line of the adjacent side divided by the line of hypotenuse. And tangent, if we talk about the ratio between this angle and this angle here, this side here and this side here, the opposite over adjacent, we call it a tangent. Tangent theta equal the line of the opposite over the line of adjacent. Finally, we have three more. So let me shortcut this one a little bit. I abbreviated to make room for something else. So this one, the opposite over hypotenuse. Now if you organize this one, you remember a lot easier. Now we go backward here. When you talk about reciprocal, cosine, cotangent. Okay, this one you go tangent. Okay, tangent. The shortcut is tangent of theta. Cotangent of theta, this one cotangent, okay? Cotangent of theta equal the flip over A over O, okay? Cotangent theta. So next one, when we talk about reciprocal of this, we call the reciprocal of this. So cotangent theta, this one becomes secant of theta equal hypotenuse over adjacent. We talk about ratio between this and this, which is secant. Reciprocal of cosine is this over this, secant with this over this, you know. And finally, cosecant of theta equal hypotenuse over the opposite. So now you pay attention to here, so you don't confuse. So now reciprocal sine is cosecant, and reciprocal cosine equals secant. So you see S becomes C and C becomes S. People usually think reciprocal sine secant because this is S here and people confuse, so they don't confuse. When I talk about value of secant, you can find the value of cosine first and you flip over. Okay? Okay? Now from later on we come back to this and we develop the identity of the trig function. Okay, now secondly, I'm talking about definition of number 2. Definition number 2. Of trigonometric function. So now we deal with different kind of angle. The angle can be any angle. We talk about any angle, negative, positive, you can be infinity. Okay? The angle can be go to infinity. So this one in section 6.1 we already learned what mean by angle in standard position. So now we have the coordinate system like this, and you put the angle have two sides, right? So if you put it here, we call this one initial side, and this one the terminal side. So angle can open like 30 degrees, 60 degrees, 90, 120, 150, 180, and 210, 240, 270, 300, 350, 330, and 360. So you can go around 360 and go 369, 400, and on and on and on to infinite. Many angles we're going to learn later on. Okay, but actually we very interested in the angle around maximum is 720 degrees only. Okay, but anyway, you know the idea of this is the angle can be any angle. So if you go clockwise here, we consider this a negative angle, negative 30 degrees, negative 60, negative 90. So now the negative 90, the same thing with positive 270. Okay, so you see that you have negative 90 degrees have to be equal 270 degrees positive. If you change into negative, you want 330 degrees positive, have to be equal negative 30 degrees. So you go 330 degrees, you go all the way around from here to here. So you have 330 degrees. Therefore, this level overhead backward here equal negative 30 degrees. Okay, because this angle now always start from here. You go backward here, negative 30 degrees. If you go counterclockwise and you get 330 degrees. So that is the relationship. Two of them the same. Okay, so now definition 2 about this angle here kind of different from the first one, because the first one you never have any negative angle, or you never can have the value of sine, cosine negative, but now here different now. So let's say I have an angle in standard position, the angle moved up to here. The point here on the circle is the point X and Y. Okay, so now we connect that point to the origin. So we call the distance here is R. Clearly R could be the radius of the circle, right? So the point X and Y move around here. So definition 2. Okay, definition of angle in standard position. Definition 1 is about the angle in the right triangle, acute angle. This one any angle. So we call the ratio of the point Y over the line of radius equal Y over R. That is definition 2. Then the cosine theta equal X over R, and tangent theta equal Y over X. And then again you go backward like this, easier. Cotangent theta equal X over Y. Now secant of theta equal R over X, and cosecant of theta equal R over Y. You see, you flip over reciprocal to each other. Okay, that also mean sine of theta equal 1 over cosecant of theta, and so on, the whole thing here. Cosine of theta equal 1 divided by secant theta, the same meaning. Okay, we call reciprocal identity. We study later on. Okay, so here is, you can see clearly. For example, if you see the definition here, look familiar with the old one. If you create the right angle here, right triangle here, and the opposite is Y, and the adjacent is X, right? So you can think about sine of this theta here equal Y over R, cosine angle here equal X over R, tangent of this theta here equal Y over X, cotangent theta equal X over Y. Look the same. However, the triangle here not there, because we talk about the point, but you still can draw a triangle to feel familiar with it. So this one I call the reference triangle. Okay, now look like we look like the same with the first one when the angle in here. So now how about when the angle theta go into the second quadrant? Remember this one we call the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, right? So now again, the same application, same definition, sine theta equal y over r, okay? Equal y over r. So now in second quadrant here, the same with the first quadrant, because y still positive. You see, you can think about the triangle here, a reference triangle. Okay, not about the triangle, but to be more comfortable, we just put y right here. So the same thing here. Sine of theta here equal y over r, just like here. And cosine theta, this one h here, right? Cosine theta equal h over r. Look like you have the triangle here. This theta here we call the reference angle here. Okay, this one the one we study, but this one we call the reference angle. It might be the axis. So now cosine this angle, not that angle. Okay, equal h over r. But in this case, that's different from cosine of this angle. Why? Because h here is positive, right? In quadrant 1, h is positive, right? But in quadrant 2, h becomes negative. Can you see that? So therefore, that's different. Different between dependent quadrant. So now, I suggest you to use this method here to remember which function here positive or negative in what quadrant. So the best way to do is you remember the coordinate of x and y, right? So you have in quadrant 1, this one x and y, okay? Any point x and y. Okay, in quadrant 1, x has to be positive, also y positive, right? And tangent equal y over x, cotangent equal x over y. Therefore, all of them positive in quadrant 1. How about quadrant 2? So x become negative, y become positive, right? So therefore, cosine is x here have to be negative in quadrant 2. Y sine still positive in quadrant 2 because value y positive in quadrant 2. Y positive, y negative, x positive, x negative. Okay. So in quadrant 3, both of them negative, and in quadrant 4, x is positive but y negative. You see that this is the way you should remember. Okay. For example, I say in quadrant 3, tangent has to be positive because tangent equals y over x. So y negative, x negative, therefore tangent has to be positive. So tangent positive here, and also cotangent also positive because they reciprocal to each other. Okay, you remember only one thing about this, and you remember everything. Okay. So now how about secant in quadrant 3? So secant is reciprocal cosine, but cosine is x. Cosine is about something to do with x and sine y. Okay, this r here always positive, so we don't worry about r. R is a line, always positive, but the negative or positive depend on x and y. And x and y negative or positive depend on what quadrant they are in. Okay, what quadrant of the angle. Now let's see. Let's talk about the angle. Go from here. You start from here. You move all around down here. So now the angle look like this, all the way from here to here. Let me estimate about 240 degrees. So now you see cosine of this angle here equal negative because cosine related to x. Sine of this angle here equal negative as well because y is negative in here. Tangent of this angle here is positive because tangent equal y over x. Okay, in that way you keep working on this one and you remember everything about the function